hormone pulsation. That little nucleus that the doctor said he didn't think it had any function, its primary function is the control of growth hormone. That's why all these animals are short, because it suppresses the pulsating release of growth hormone. And of course, we said it can alter the pathways. Now let's look at the hypothalamus. The hypothalamus of your brain, if you had to pick a part of your brain that you said was probably the most sensitive to any injury, it'd be the hypothalamus. Doctors kid about it being the seat of the soul. It's about the size of your fingernail on your little finger. It's not very large. But it controls an enormous amount, and you cannot live without a hypothalamus. Major injury to the hypothalamus, you're going to die, short of the intervention of the Lord. If we look at the functions of the hypothalamus, we see that it controls all of the endocrine system, right? Your growth hormone, thyroid hormone, adrenal hormones, cortisol. All of these things are controlled through the hypothalamus. It controls your sleep-wake cycle. Tells you when to wake up, tells you when to go to sleep. If you have an injury of the hypothalamus, you'll stay awake all the time. Or you'll sleep all the time. So it's very important. It controls your hunger and satiety. It tells you when you're hungry. It tells you when you need to eat. And this is part of the thought of anorexia nervosa, if they have a problem in the hypothalamus. We know that it controls the autonomic nervous system. In other words, all these things automatically makes your heart beat so you don't have to think about it. Things that make your intestines move along with peristalsis so you don't have to think about it. Those are automatic reactions, parasympathetic, sympathetic system. That's controlled through the hypothalamus. And we know that it is a major part of what we call the limbic system of the brain. That's the part of the brain that has to do with your emotions. It has to do with love, anger, fear. Is regulated through the hypothalamus. And if you give MSG to animals, you can produce intense fear or you can produce intense anger. And lastly, we know, and this is something fairly recently, that the hypothalamus controls immunity. There's a whole field of psychoneuroimmunology. And this is part of what, if you're under stress, your immune system's depressed, you're more likely to get cancer, more likely to get infected, more likely to not recover from your infection or your cancer because your brain, your emotions connects to the hypothalamus and that controls your immunity. We find that in experimental animals, if you take that hypothalamus and you expose the animal to MSG, it will cause a suppression of immunity that will last the entire lifetime of that animal. And if you think about that in humans, if you have a baby exposed to MSG during these critical periods, that could affect their immunity forever, so that they'd be at higher possibility of getting infections or cancer. If they got a cancer, they have more difficulty recovering from it. So you're talking about some profound life-altering changes here. Now, one of the things that's really intrigued me is the effect on intellectual development. And if you look at the brain, you see this enormous complexity. We've been studying the brain probably for the last 70 years intensely. We're just getting a glimpse in the window. It is so enormously complex. There's nothing in the body even approaches the complexity of the brain. But what we find is that early on is that when MSG exposed babies are tested, they find that they're intellectually impaired. In fact, this doctor said that it appeared as if the animal was intellectually retarded. And this experiment, which is a two-part experiment, was very interesting. She took animals that were pregnant and exposed them to MSG and then tested the offspring and found that the offspring initially looked perfectly normal. And when they did this simple little test for intellectual function, they passed with flying colors. But when they tested them for more complex problem solving, the animals were severely impaired. Now, if you transpose that to a human, what that means is if your child is born after exposure to MSG or after being exposed to MSG after birth during that first 4 years, you say, well, the child looks normal. He's going to the different little grade schools and seems to be able to learn his ABCs and count and learn his name and do simple spelling. Seems to be intellectually normal. But then when he gets into higher school and has to do higher math, has to do logic, has to do intense cognitive functioning, they're impaired. Now, who is going to look at that and say it was due to MSG exposure when the baby was a child, when no one will let this story out? No one knows this was done. The second part of the experiment, she was curious why this happened. So she measured the neurotransmitters in the brain in these offspring to see what happened, and found that there was an 80% reduction of a transmitter called acetylcholine in the frontal lobes of the offspring's brain. Now, acetylcholine is absolutely vital for learning and memory. There was also a reduction in a neurotransmitter called norepinephrine. Norepinephrine is what allows you to pay attention, to concentrate. So if you cannot concentrate on a topic, then you're not going to remember. And this is what's happening. I'm going to have to move a little faster than I planned on. I always talk longer than I plan on. Now let's move to adults. So we know that children are 4 times more sensitive. Look at some adults. The brain is at risk for these different reasons. Now, one, the brain has one of the highest concentrations of polyunsaturated fats. It's about 50% polyunsaturated fats. Polyunsaturated fats are easily oxidized. You're all familiar with rancid, things becoming rancid. Well, that's what oxidation of a fat does. Well, in your brain, you have a very high concentration of oxygen, one of the highest concentrations of any organ. It consumes 20% of all the oxygen in your blood, even though it's about 2% of the weight. So it's consuming enormous amounts of oxygen in the face of those polyunsaturated fats. So they become very easily oxidized. Brain normally has iron in it, but the iron is protected by being attached to a protein. As you begin to get older, that iron is released, and you get free iron in your brain, which is very dangerous. The older you get, the more iron is released. Iron is one of the most powerful generators of free radicals, and that's thought to be one of the reasons why the brain starts aging, and you have these problems with brain aging. And aged brain cells are more sensitive to free radical damage than a young brain cell. Much more sensitive, about 4 times more sensitive. This is just some of the changes that occur when your brain ages. You lose some of the receptors. The cell membranes change. They become stiffer. It's difficult to get the nutrients into the cell as you get older. The cell cannot produce as much energy as it used to. There's accumulated free radical damage over your entire life, so that you begin to damage the DNA, damage the protein, damage the lipids, and this accumulates throughout your entire lifetime. And remember, we said the way that excitotoxins kills the brain cell is by generating lots of free radicals. So you're speeding up this aging process significantly when you're exposed to those substances. Now we know that there's 3 things that are associated with increased excitotoxicity. We already said an immaturity of the brain makes you 4 times more sensitive. Second is energy deficits. Anytime a brain cell has difficulty generating energy, it becomes infinitely more sensitive to excitotoxins. So if you have low blood sugar, if you're running a race and you didn't eat properly and your blood sugar is falling, if you're dieting severely, if you have a disorder of your mitochondria and you can't produce the energy, whatever the cause of a lack of energy in that brain cell, it's going to magnify the excitotoxic process, and it can magnify it as much as 100-fold. It can magnify it so much that even a normal concentration of glutamate in your brain can be toxic. Magnesium deficiency is the third thing. Magnesium deficiency in this country is very common. A recent review showed 75% of people are magnesium deficient. Magnesium protects that little pore where the calcium comes in. It closes the hole. If you take a human being and you make them hypomagnesic, that is, you remove the magnesium, they will have a seizure, and they'll go into a coma. And before that, they'll become psychotic. And this has been done or seen many times in clinical patients. And if you give them magnesium, they turn back to normal, if you do it in time. And that's because magnesium prevents this excitotoxicity process. This is just the cycle we've already talked about, that excitotoxins cause free radicals. Free radicals damage things inside of the cell.